And while we're talking about functions and variables, I'd like to talk a little bit more about global variables. For example, let's make this variable today a global variable. Simply move it from its current declaration inside main function and place it somewhere in global scope. And let's also for now remove function square from our program and simplify our main function just to the basic return statement. So this is now global declaration of a variable today. Let's just say, for example, that we have a number of functions in our program, function f, and likewise function g and h. I'm just multiplying them for the sake of our demonstration. So if now each single one of these functions begins to access or modify variable today, so basically just to illustrate just like this, right? So this function and this function and this function continues to modify, access, read and write the value of the variable today. It is relatively easy to write such program and make it work. However, what could be difficult down the road is that there could be very challenging to maintain this program. For instance, if I want to make some changes to a certain place in the program, and as a result I have to start adding new code, modifying existing code, for me, in order to be sure that everything that I do is safe and structurally sound, now I need to examine every function in my program and make sure that I examine each place where this variable is accessed and continue to verify that everything that has already been in place continues to work correctly. This phenomenon is kind of known as a bad design pattern known as data spaghetti code, which means that it is hard to predict who and when will attempt to change the value of a certain variable. And imagine if we have multiple variables and multiple places where such modifications take place in various places of our code, the problem exemplifies it. And since such code can be hard to maintain, understand, and make future enhancements, conventionally programmers establish some good practice rules made up of restrictions, constraints, agreements, and things of similar nature. However, these rules cannot be enforced by a procedural programming language itself, because we already said that such restrictions simply are not built into C programming language, meaning that every part of the program has unrestricted access to global variables that exist in scope. And we can make an observation that not every function needs access to every global variable. So some new ideas were brought by C++, which brings a set of new rules that we can establish as and take advantage of as part of the programming language itself. So let's start over one more time to demonstrate. C++ adds this new possibility that we can have functions declared inside a data structure. And by the way, such data structure typically is written as class. So the class is the same as structure, but normally includes member functions declared directly inside the date class. For example, I could add a member function such as, for example, void add a certain number of days to already existing date. So the difference between member functions and global functions or free functions is that this function is restricted to access these variables, and they actually become, their scope also becomes restricted. So we can say that these variables are private. Okay, so by default, inside a class, the variables are private. The meaning of the private access modifier here is that only member functions of the class can access private variables declared inside the class. So this is an idea of a class. Just like a structure, class defines new user-defined data type. This user-defined data type provides a possibility to declare a certain number of variables and also provide member functions which allow us to manipulate these variables. So before, we kept these three variables part of the structure and we kept them in a global scope, globally available from anywhere in the program. Now, as we made these three integers part of our class, now there is a restriction enforced directly by the C++ programming language, which would allow only member functions placed inside the class declaration to access these variables. The presence of a date class declaration in scope of our source file does not automatically mean that an object of this type will be created. Just like before, as we did with the structure, we need to provide a declaration of variables such as today, or possibly we can add another date tomorrow, and so forth. And we can start using today and tomorrow just like variables which have a type date, which is a user-defined data type presented by the declaration of the class. Class is a blueprint of an object. The object itself has to be created, just like this. There are multiple ways of creating an object, but these are examples of declaring two local dates inside local scope of function main. And basically, we have to declare our objects just like we would declare normal primitive data type variables. For instance, integer counter. Right, so this is a primitive data type, integer, and the variable is named counter. And likewise, today and tomorrow are also local objects, and they have the type date, which is described by this blueprint. In other words, the class name date. Once again, to summarize here, the general rule is that objects must be created before they can be used. Objects are not created automatically. They need to be created. Another term for their creation is instantiation. We can say, for instance, that function main creates object today. It is synonymous to say that function main creates object or instantiates object named today. Program defines class only once, and then program can create multiple instances of objects of that class. Right, so we have a declaration of the class right at the top, and then once it's declared, we can have more than one instance of an object created, which creates a quite nice possibility for manipulating program memory, which is allocated to these objects. Of course, in addition to this, we can create multiple classes in our program, and put all together that provides a groundwork for object-oriented program, which means that a lot of work will be concentrated and managed by these objects.